So today we're going to keep talking about the second type of essential functions, the power functions. Actually, we talked about the linear function. When the linear function takes m as 1 and b as 0, then it's y equal to x. This actually is a special type of power function because the power of x here is just 1, right? We can generalize the expression of power function as f of x is equal to x raised to a power of a. So x is a variable and the sign a represents a constant over here. So when a is a positive integer like 2, 3, 4, 5, then it depends on whether a is an even number or an odd number. When a is equal to 2, y is equal to x squared. The graph of this function should be a parabola. When a is an odd number like 3, y is equal to x raised to the power of 3. The graph of this function actually is not even anymore. It's an odd function. It's symmetric about the origin of the coordinate. So it goes this way. What if you want to have y is equal to x raised to the power of 4, 6, 8, 12, and all these other even numbers? It would take approximately the same shape of the parabola over here. Alright, so guys, let's take a look at the second type of a. What if a is equal to 1 over n, where n is an integer? For example, y is equal to x raised to the power 1 over 2, which essentially is square root of x. And the graph of this function should be approximately like this. The domain of this function actually is from 0 to the positive infinitive. What if we have y is equal to x raised to the power 1 over 3 is essentially the cube root of x. The domain of this function can be real numbers. So it can be positive, it can be negative. So the curve of the graph should be over like this. We're going to keep talking about the other types of power functions in the next video. See you guys later.